Hola, we're back.
Okay, so here is probably our least favorite part of this whole chapter because it's the hardest part. It's refraction and lenses. So go ahead and get your next notebook paper up and label it 4-3, chapter 4, section 3 if you want to refer to your book. Refraction and lenses.
And remember, we just talked about how important it is that you are making sure your notebook is nice and neat and organized.
Yep, you can do it.
Don't make us hurt you.
Okay, so this is a pretty classic example. You've probably seen a fish tank somewhere in your life. And you notice like sometimes there's weird things that happen. Like in this fish tank in the picture, there's really only one fish in the tank, but if you look at it at a certain angle, you definitely see two.
Mm-hmm. It's like he has a little friend in there that doesn't exist.
I have a friend.
I don't tell kids that.
Oh, okay. Only I could see her. Okay, so we're going to kind of see the science behind this friendship here, the fishy one. I'll see a doctor for mine. Okay, what refraction of light? Did you notice it's not reflection of light, but this is refraction of light? Refraction is a different thing than reflection, so you really have to be careful when we talk about refraction and that you're getting that handled correctly, like your spelling and everything. So when does light refract? It can't bend when it wants to. Light can only bend when it is going through a new medium. Do you think they remember what a medium is, this part?
I don't know, but just in case they don't, a medium is anything that a wave travels through. So like air, glass, a solid.
Yeah.
So things like that. So if you think back to your fish tank and you have light waves that are traveling through the air, and then they go into the glass, and then they go into the water, and then they go back through the glass, and then they go back into the air. There's 3 different types of mediums that are occurring right there in that itty-bitty situation.
Right. Okay. So, but not all light is going to bend the same way. So the index of refraction, this is actually a level 4 terminology, I'm pretty sure. You have to check your proficiency scales. The index of refraction is a measure of how much the light bends. And this depends on the material that it's going through. So light will bend differently in like glass than it will in water. And it will bend differently like in corn syrup.
Yep.
Corn syrup?
Yeah.
Corn oil.
Corn syrup.
Okay. Yeah.
Vegetable oil.
Vegetable oil. I think you can make corn oil too. Okay. So this is a very like a mirage. That's how you say that word. It's a mirage. It makes me think of Bugs Bunny when I was a kid. We watched a lot of Bugs Bunny at my grandpa's house. And Bugs Bunny would always be in the desert. I don't know why. And then he would see like a mirage, which is that water on the street in the distance. So the mirage is called by is the refraction of light. So, but it's not going through a different medium. In the desert, there's only like air and the road or the dirt or sand. So, but the air itself causes the light to refract because of different temperatures of the air. So how do we word this?
Which is why most mirages happen in the desert, is because of the amount of heat found in the desert. The air particles are different than they are in other landscapes.
So the air up here in the atmosphere is cooler marginally, not like significant. It's not like 16, it's like 100 on air. But it is cooler enough where the speed of light will be different than when it gets to the hotter air right by the road, because that road like holds in the heat, which heats up that air there.
And sand holds in heat too. So.
Oh yeah. So I'm always thinking of the road.
I know.
And he always dives into the water, and then he bucks and gets that bruise thing. But that's what causes a mirage, is all the bending of light in the air itself. So here is a table. You do not need to write this down by any sort of way, but you can just let you know this is an index of refraction of different materials.
But you do need to know how to read this table.
Yes.
So the index of refraction tells you here at the top which one it will bend the most in and which one it will bend the least in. So the lower the number, the less of the bend. The higher the number, the more it will bend. So it changes the angle at which the light ray bends.
And look at this. These are two numbers that are exactly the same. Corn oil and glycerol is a type of alcohol? Like
no,
sugar?
like bubbles can be made out of glycerol.
Oh, you're so smart.
So like
She's smart.
blowing bubbles.
So if we put like corn oil on top of glycerol, and I don't know which one's more dense, but if light was to travel between the two materials, it's not going to bend at all. But if we put corn oil on top of water, then you're going to see light bending. And we actually have an activity for you to do in the next, I think it's the next activity, maybe it's not. That is where you're going to layer some things and see how light is going to bend. Now look at this. Look at the highest index of refraction on this chart. It's the diamond. Now if you think about that, when you get a diamond, they don't take it off the ground and put it on your ring. They actually cut it in several different ways. Now think about every cut they do on that diamond. The more cuts, the more light is entering at different angles, the more light is coming out in different angles. That causes that shininess of diamonds and that sparkliness. So a lot of your precious jewels are cut a lot of times in order to get that index refraction and getting the most bang for its buck.
Yep.
What I find interesting is that the rest of your team is sitting in your room and you are not there.
And we're taking a video.
We're videoing right now.
Okay.
That was Miss Hoffman. Don't
She's
listen to her.
So rude. Okay, so a rainbow is caused by the index of refraction also. So if you look at this pretty droplet on this you can't see when I'm pointing. Here's a water droplet right here. And you got white light coming from the sun, coming into the water, and then the light bends as it goes out.
Can I look at a menu and send it to you?
She wants to know what she wants for lunch.
That's important things here.
Anyhow, so you could answer these questions in your notebook. Why do you think the light separates out into the colors at point A?
And this is a pretty cool concept because the next time you see a rainbow, you're going to be like, I know why that happens.
Science is pretty cool. And then look at point B. It's actually reflecting here at this surface, and then it's refracting another time when it gets to point C. So light's being bent a couple times here, which is so super cool. Okay, a lens. I'm not spelling it wrong. If you notice, it says lenses up here. That's more than one lens. A lens by itself is singular. So I kind of do know what I'm talking about sometimes. It's a transparent.
Think about what transparent means. You should know this.
Glass, plastic, that bends light.
So think about some things that you know that have a lens or lenses. So if you wear glasses, that is a lens, okay? And in fact, actually a contact would be considered a lens as well.
Well, they're called contact lenses.
Yes, okay. Let's see, what else is a lens? A magnifying glass, is that a lens?
I was working on spelling it. Magnifying glass. Oh, in your camera. That clear
yes.
part. Oh,
yes.
in your eye. So I don't know when you're taking these notes. I'm assuming it's after our challenge field trip. So you should have seen the dissection of the eye, and you would have seen that clear part of the outside of the eye is that's the cornea. But then you have the lens in the middle part. So you would have, hopefully he would have pointed out the eye. We haven't been on the field trip yet, so I don't know. But the eye has a lens. So those are a few. You can list some more if you wish. Okay, convex lens.
So think back to when we talked about mirrors. We talked about the words convex and concave. So just a refresh for you, convex means that it bends outward. Okay, so like a hill or a mound.
I'm going to add the word lens. A lens that bends outward. Okay, and this is really confusing. Okay, so look at the light. They have 3 laser pointers coming at this direction towards the lens. So this is the original source on this side, on the left. And as they go through the lens, the red bends down this way. The green guy gets to go straight, and the blue guy bends up that away. Do you see how they end up over here? This is your focal point. They end up switching spots. So a convex lens can create an upside-down image, because really, if you think about it, the blue used to be on the bottom, now it's on top.
Yep.
So, can it create real, virtual, or both? I just told you, both. It's going to create both images. You're going to want to, don't just write the word both down. You want to write this whole question, and then maybe write the word both, or circle both, okay? So the other type of lens.
Okay, concave lens. Think back once again when we talked about mirrors. Concave means to cave in, so it's a lens that's shaped like a bowl.
Oh, all caps. And it might not be a a huge, overly pronounced caving in. So when we do the lenses exploration, I often, if you ask me which one's which, I will feel them so I can feel if it's caving in or bubbling out. And you might need to do that when you try to determine if it's concave or convex. Look at these light rays, red, green, and blue again. Green guy gets to go relatively straight. Red guy, it looks like he's going upwards. Blue guy is going downwards. If he's going up and the blue guy is going down, they're never ever going to cross.
Right.
So the image will always be upright. And upright is virtually the same. So
Remember, crazy words with real or virtual here. Virtual means that what you're seeing on the other side is what went into the left side is now what you're seeing on the right side.
Yeah, you'll never get a real image on this. Always virtual. Okay, so here's some images I want you to draw in your notebook. So you're going to pause this, and this is figure 18 in your textbook and figure 19 in your textbook. And I think it's chapter 4.
And this is in your blue textbook, the actual textbook that you have with you.
Right. So draw and label these. Make sure you label which one's the image, which one's the object. Sometimes the image gets to be the same size. Sometimes the image will be bigger. Sometimes the image will get to be smaller. So you need to be able to decipher these diagrams. You won't need to be able to regurgitate them and memorize them, but you should be able to understand how to read them, is what we expect.
And the big difference between the images that you're drawing here is pay attention to where your focal point is in regards to the object.
Boing.
That's what changes the image that is ultimately produced along with the type of lens.
So pause it, draw those. Oh, and that's it. Okay, so if you have any questions, make a list of your questions. Do the next exploration over like using some lenses. I think we have 2 there for you. If you don't understand lenses, come and talk to us. We want to make sure you get this because this is the trickiest part of the whole entire unit.
But make sure you do the exploration first because the exploration might answer some of your questions.
It's hands-on. It makes it much more logical. Okay, kids, have the good rest of your day. Talk to y'all later.